Let's look at more details about the ELF file format. The ELF header is always at the very beginning of the file, so starting at byte 0 of the file. And that header itself starts with these 4 bytes always. Hex 7F, followed by the character E, the character L, and the character F. And if we go back over where we have a.out and just open it as if it were a text file in Emacs, then we see something that Emacs prints as $?. So that turns out to be hex 7F, and then E, L, and F are those ASCII characters, and then there's more stuff. The more stuff says more about the ELF file. In particular, when you get up to bytes 16 through 17, that's where the type was stored. So the way that readelf was able to tell us that it was an object file or an executable was looking at bytes 16 through 17, using that as a small integer, treating it as a number. The number 1 means an object file, 2 means an executable, 3 means a shared library, and so on. So we could open an ELF file and start reading these individual bytes, and jump to byte 16 and 17 if we wanted to. A better way to parse an ELF file, though, is to map it into memory and then look at it through the lens of a structure declaration. So this structure declaration, this is for ELF64 E header. So E header means ELF header for the 64-bit ELF format. And this is the same information about the bytes, just expressed in structure form. So the first 16 bytes here, because EI dent is 16, then those include the first 4 bytes, which are hex 7F, ELF, and then that's why this E type field is going to be at byte 16 in the structure, which corresponds to byte 16 of the file. It's an ELF64 half, which turns out to correspond to short, and so on. So what we're going to do is take an ELF file, copy the whole file into memory, just into some allocated space on the heap, and then cast the pointer to the beginning of that copy to an ELF64E header pointer, and then we'll be able to use arrow on that pointer to get these different fields out to get information about the ELF file. So concretely, that looks like this. This code is a little bit small, so I'll take it into the editor over here. We will call this mini readelf.c. So mini readelf.c is going to use some Unix stuff that we're going to talk about later in the semester, but it opens the file that we give it as the command line argument. We just assume that we get the file as a command line argument. It finds out how long that file is, and then it uses the operating system's mmap function, which takes the whole file, maps it into memory, and gives us a pointer p to the space that was allocated to store that file. Turns out it moves the file into memory lazily. That's the great thing about mmap, but we don't care about that. We can just view p as a copy of the file in memory. And then now, here I'm casting that pointer p to an ELF header, and then I can look at that EIDENT field that we saw, make sure that the 0th byte is hex 7F. The next one is the ASCII letter E, and so on. If those 4 things don't match, then we can make our mini ELF complain that it's not an ELF file. And then mini readelf is just going to look at the type field. That's the one that's at byte 16, and see whether it's ET-rel, ET-exec, and so on. This structure definition and all those constants come from elf.h, which is on your file system as user include elf.h. So if we look here, go down a little bit, you'll see that there's 32 and 64 bits of everything. So you want to pay attention to the 64 byte parts, and this is ELF64 E header as we saw on the slide. And you can see there's other things like this is where did that type come from? So this was ET-rel, ET-exec, ET-dyn, and so on. That's how we got all of those things. Let's try our mini readelf out. I think I need to save it. So mini readelf. Let's write it to mini readelf. And if we use mini readelf on a.out, which we compiled before, then we're able to say that that's an executable. If we try it on demo.o, it'll say it's an object. If we try it on demo.c, it'll complain that that wasn't an ELF file because it doesn't start with the right 4 bytes. demo.c was copied into memory, and we started looking at those bytes, and they weren't the magic number 7f followed by elnf.